Hello, my name is Asaida. I'm from Physics Department, University of Sriwijaya. Please allow me to present our work. The title is NOMA Implementation in OFDM MIMO VLC Network Serving 9 User Equipments. My presentation will be consist of 3 sections. First, the brief introduction about this research. Second, how the research was modeled and simulated. And finally, what is the result of our work. Wi-Fi, as we know, already popular use in every campus, office, mall, and private house. In a house, TV, laptop, and mobile phone are connected to internet via Wi-Fi, but the problem called Wi-Fi spectrum crunch appear as the connected devices increase. This device require broader bandwidth as VLC can provide. The radio frequency that provide conventional communication bandwidth is no longer sufficient nowadays. Therefore, feasible like communication, which has 10K times RF bandwidth, now become an alternative to complement RF communication. VLC is cheap since it uses like lighting facilities. It is safe because it is electromagnetic free. Therefore, VLC systems will in the future can be applied in private houses, offices, hospital, airplane, basement, and other environment where electromagnetic waves is restricted. So the objectives of our research is to obtain the parameter and analysis required for VLC implementation serving 9 users. The simulation result considered as a valid result since our previous experiment had been demonstrated for one LED serving 2 user equipment in 2020. In the past, we had modeled a research where one LED serves 2 or more users by differentiate their signal power using NOMA mechanism. In the experiment, we had demonstrated our work where one LED served 2 user equipment, UE1 and UE2. And as we can see in this figure, AWG send data signal to white LED, then LED transmit the signal to PD1 and PD2, represent as UE1 and UE2, and then the received signal captured by RTO, real-time oscilloscope, and the data will be decoded using computer. In order to serve 9 users in total, beside NOMA implementation, a MIMO network is used with configuration 3 by 3, meaning there are 3 LEDs role as transmitter A, TXB, and TXC, each of them serving 3 user equipment, UE1, UE2, and UE3. If we consider the transmitted signal from TXB and TXC is as 100%, at some point where UE1, UE2, UE3 can receive signal from its neighbors, the percentage will decrease into some level like 100 minus Z% here. So in this research, the level of interference from the neighbor are varied and about to find out in the simulation result what is the minimum SNR, what is the minimum SNR required from the transmitted signal to hold the level of interference from the neighbors TXB and TXC. So the modulation technique used in this VLC system is OFDM NOMA as shown in the schematic diagram. The data for each user is mapped into a symbol before fed into IFFT to produce OFDM signal. Then the signal of every user is allocated with different power by multiplying each signal with A1, A2, and A3 to produce X1, X2, X3T. And these three signals will be superposed to get one transmitted signal, XT, uh, to, to be sent into VLC channel and received by every user, UE1, UE2, UE3, as Y1T, Y2T, and Y3T. In the receiver part, since UE3 is allocated with more power P than others due to its low SNR, so the receiver can directly decode YT3 uh, through zero forcing algorithm by considering X1T and X2T as noises, while UE2 and UE1 must perform SIC algorithm several times to subtract other user signal which has higher power allocation. SIC procedure is intended to find the original signal of user which has higher power, in this case XT3 here, to subtract it from the received signal YIT to decode XIT, where I refers to the user with lower power allocation. So what is the result of our simulation? As we can see in figure 7, the bit error ratio performance of three user equipments, UE1, UE2, and UE3, served by TXA with zero level of interference, meaning these three user equipment do not receive any signal from the neighbors. So we call it as zero LOI. So with this situation, the minimum SNR of received signal here must be above 25 dB to obtain bit error ratio below FEC limit. If we increase the level of interference into 1%, meaning UE1, UE2, and UE3 receive 1% signal from TXB and 1% signal from TXC, each of them. So to maintain the bit error ratio below FEC limit, the SNR signal to noise ratio of every received signal here must over 25 dB. So still the same with the previous one. In case the LOI increase into 2% level here and here, so the signal to noise ratio of received signal of UE1, UE2, and UE3 must be above 27 dB. Otherwise, the bit error ratio will be over the limit of fast forward error correction here. And finally, when the LOI of the neighbor is 3% here and here, received by every user here, the user 1, user 2, and user 3 SNR must be above 27 dB to obtain bit error ratio below FEC limit here. So the required SNR still the same with the previous LOI. How about the constellation diagram of fork pump that we use in the simulation? As we can see from figure A and figure B, every user constellation is described here. We can see that when the interference level is low here, the constellation point is clearer compared to the B, where the LOI is high. And we also can see that UE3 here um, has many constellation points compared to UE2 and UE1. This is because UE3 decoded UE2 and UE1 signal at the same time because zero forcing algorithm is applied. But in the UE1, since its receiver subtract UE1, UE2, and UE3 signals, so its constellation point is similar as the original for quantum point. So, as conclusion, the numerical work of NOMA MIMO VLC network serving 9 users based on DCO or FDM scheme had been conducted. Analysis of the bit error ratio performance in different channel noise and interference level variation LOI from two LED neighbors showed that to achieve BER below FEC limit, the minimum SNR should be above 25 dB in 0 and 1% LOI, above 27 dB in 2% and 3% LOI, while to have NOMA implementation work in the system, the required power ratio of every user must meet this ratio to maintain the bit error ratio under threshold. And as future work, this result will be a baseline for carrying out the experimental implementation by setting the proper distance between multi-LED in VLC network and determining the required SNR of LED as the transmitter. So this is the end of our presentation. Thank you very much.